A warm welcome to all my dear friends. Today we are going to discuss a CodeChef problem from July long challenge, that is Chefina and SWPS. In this problem we are given two sequences of same length. We want to make them look identical after sorting them in non-decreasing order. For this we can swap any of the integers from sequence A with any integer of sequence B, but it will cost us the minimum of the two values. So basically what do we want? We want that both the sequences should have same frequency of numbers with minimum cost. What comes to our mind after reading the question? It means that each element should be present even number of times, because if the elements are present odd number of times, then they can't be distributed evenly to two sequences. I hope you are getting me. So basically, if any element is present odd number of times, then the function would return -1 as it is given here. Okay, yeah. So secondly, we need to find the minimum cost with which chef can make two sequences identical. We need to find only minimum cost, not the minimum moves. So we can have any number of moves, but the cost should be minimum. Let's discuss one test case. Okay, so first here three test cases total. So first one would have one element in each sequence. The first element of first sequence is 1 and second is 2. So is there any way so that we can make these sequences equal? I don't think so. That's the reason they have given -1. Okay, second will have two numbers each. First is 1 and 2 and second is 2 and 1. So in this we have same frequency of numbers in both the sequences, so it means that we need not do anything. When we will sort in non-decreasing order, they will become exactly equal, so we have zero cost in doing so. The next one is 2. So here the first sequence have two ones and second have two twos, so we need to swap 1 and 2, 1 from the first sequence and second 2 from the second sequence. Okay, so in swapping these, if we'll swap this one with this 2, so what will happen? Minimum cost will come to be 1. Okay, because minimum of 1 and 2 is 1, so here it is 1. Okay, so now let's have one more test case, my own test case. It is like we have one test case, each will have 4 elements. First one is 1 6 6 7. Sorry. Second one is 1 5 5 7. Okay, so pause the video now and think what would be the answer according to you. Okay, so I think you might have done this. So some of you might have got 5 as the answer, but what if I say the answer can be 2? Are you shocked? Yeah, carry on with me to know how. There are many methods of making these two sequences identical. Okay, but we can do it by a single swap of 6 from the first sequence and 5 from the second sequence. So what would we have? We would have 5 and 6. Minimum of 5 and 6 is 5, so the answer will be 5. Okay, agree. But what if we swap the 1 from the first one and 5 from the second one? So the sequences will become 5 6 6 7. Second one 1 1 5 7. Okay, now again we replace this one with this 6. What will the sequence become? 5 1 6 7 and 6 1 5 7. Now see, we have equal frequencies of each numbers. It means when we will sort them in non-decreasing order, they will become identical. So now what it costed to us is, here we replaced 5 and 1 and here we replace 1 and 5. Yeah, 1 and 5. So the cost will be 1 here, 1 for this one, and for this one also 1, because we replace 1 and 6 here. The total cost will be 2 by adding both of these. So do you understand? Here I wanted to prove that number of swaps doesn't matter to us in this case. What matters to us is we need to have minimum cost. Okay. So my approach to this question is that what if we make an unordered map in which we store frequencies of both the sequences and then compare half the frequency of that map with each sequence, like in here, like here we got frequency of 1 is 2 and frequency of 2 is 2. So by halving that we get that frequency of 1 in each sequence should be 1 and frequency of 2 in each sequence should be 2. So by comparing, this one comes like, I think we should go coding. Okay, so let us include some basic headers. IO stream, that is include standard library, do algorithms, including maps, unordered maps as well. We need a iterator for the same. Okay, we would require vectors, I guess. Okay, if any other would require, we'd add later on. So using namespace standard. So first we input the test cases denoting T. So T. Next we input single integer n, then two space enter integers. Okay. Then we'll have int n, cnn. Then we'll have one unordered map and two arrays. Okay, so int a of n, one more b of n. Okay, these are two arrays. Then one unordered map. Unordered map of values long int. Int what mp. Okay, so now for then now we will have cn of a of I. Okay, and now we'll have map frequency stored in maps. So we'll do that by frequency of a of I plus plus. Okay, fine. Now we'll have another loop for second sequence. same b of I and p of I plus plus. Fine. So next we'll have we should declare unordered map iterator. Unordered map, I should copy from here. Iterator itr. Okay, now iterating it for itr is equal to mp dot begin. Itr is not equal to mp dot end itr plus plus. So if now we'll have that even odd condition. So if itr's second, that is the frequency, on dividing it by 2, the remainder is equal to 1, which means if the frequency is odd, okay, if the frequency is odd, then break. Other we should have one flag. Okay, we need to add one flag is equal to 1. Then here flag becomes -1. Fine. Otherwise it will have ITRs. We'll divide the frequencies by 2, which would give us that the required frequencies, like now which what are frequencies that are stored in this map MP. They are the frequencies each sequence should have. Okay, so now I'm making a copy of this map, like for reference. One more map declared there, then ref is equal to mp. Okay, now I'm comparing its frequency with both the arrays. Fine. So for this, for int I is equal to 0, I is less than n, I plus plus, it would have if reference of a of I so else okay, we'll store the numbers that need to be swapped in a vector. So let me declare a vector here, vector of kind long int a1 and b1. Okay, fine. So now here, if the element needs to be swapped, then we'll add that element into a vector. Okay, so here a1 dot pushback a of I. Fine. Yeah, so again referencing it for doing the same process for sequence B. int I is equal to n. If reference of b of I, reference of b of I minus minus, fine, else b1 dot push back b of I, fine. So now we've got two vectors a1 and b1 which contains the elements that needs to be swapped. Okay, so now I'll sort both of these. Okay, so for that, sort a1 dot begin, I guess a1 dot end, I guess creator int, yeah, so fine. Same we'll do for b, where it will be b1 b1. Okay, fine. Now both the vectors are sorted. Now we'll check if both the vectors should contain same number of elements that needs to be swapped. Like if from sequence A 3 elements needs to be swapped, from sequence B also there should be 3 elements that needs to be swapped. So if that not the condition, then it will return -1 because it isn't possible. So if a1 dot size is not equal to b1 dot size, fine, then b1 dot size, then flag is equal to -1. Okay, it should also return -1. Now we are checking if our program has failed at any condition, like either here where flag is -1 or here. If it hasn't failed, then we need to continue further. For that I'll run one if condition if flag is equal to 1, if it is maintained at 1 as we initialize it. Now we'll calculate the cost. So for int I is equal to 0, I is less than a1 dot size, or either you can write b1 dot size because both the sizes are equal here. So we are going to get cost plus equal to minimum of a1 of I comma b1 of a1 dot size minus I minus 1. You know why I've done that? No, okay. So there we have two vectors. So we have sorted them in increasing order. So I've picked the minimum of one array, A1 array, and the maximum of second array, so that we can get the minimum cost. Like if we swap 1 and 2, we'll get cost 1. If we swap 1 and 10, then also we'll get cost 1. In both the cases we get the cost as 1. So it would be better swapping it with 10 because there is much difference. So that's why I have done that, traversing A from starting and B from the ending. Okay, now one case left for that. That is the case I showed you, like when we have a value that is much smaller, in which we do two swaps. For that we need to have some value, that is min-val. Let's initiate it to a larger number, larger than this, 10 raised to the power 9. 2 into 10 raised to the power 9, 4, 5, 6, 7, 8, 9. Okay, so min-val is basically the minimum value from all the elements. Either it may be of sequence A or it may be of sequence B. So it will be the min of min value or A of I. Okay, same in case of B. Min value is equal to minimum of min value comma B of I. Okay, now in the cost we need to recognize that which will be minimum, the twice into the minimum value or this figure that we wrote. So for that we'll do minimum of min value comma this and that. Okay, that's fine now. So now what's left? We are almost done. So now printing the output. Say out cost and I guess we forgot to initialize the cost. Yeah, let's get it. Cost equal to 0. Initially the cost is 0, so cost. Okay, if the flag is not 1, then we need to print out -1. See out -1 and then okay, I think we are done here. Let's check this one. Save terminal. CHEF.CPP. Okay, 3, 1, 1 and 2. It is -1. Okay, right. Next one is 2 elements, 1 and 2, 2 and 1. Okay, 0, right. Element 2, 1 comma 1, 2 comma 2. It is right. Okay. Now let's discuss the example that I gave you. It was like one test case, 4 elements in each sequence. First sequence was 1 comma 6 comma 6 comma 7. Second sequence was 1 comma 5 comma 5 comma 7. So now you know what should be the output. Yes, 2 should be the output. Okay, so thank you. We have